Hello, chemistry students. This is a video to help you along with activity number 4 that is found in your Learning Organic Molecules packet. And I need to do this part of the activity with you because it requires a model kit. And again, I'm pretty sure that most of you don't have one of these at home. So anyway, let's get going. So if you need to, go ahead and pause this video so that you can open up your document in Cami. All right, welcome back if you had to pause there. So let's just take a look at our first question. How many bonds can a single carbon atom make? And remember that in my model kit, it's the black beads that actually have that represent carbon. And then remember too that I've got 4 holes in each carbon. Every carbon atom can make 4 different bonds. So your answer to number 1 is 4. All right, it says to use the model kit to create hexane, which is what I did. And the model is here. You have to think, like, what does the prefix hex mean? And that means 6. So I had to link 6 different carbon atoms together, which is exactly what I did. So number 2 says count the number of carbons. We have 6. And then we have to count the number of hydrogens. Well, I have 3 hydrogens on each side. So that's 6. And then I have 2 hydrogens on each of the 4 carbon atoms that are in the middle of the molecule. So 6, 7, 8, 9, 10, 11, 12, 13, 14. And from activity 1, you could have just used the formula 2n plus 2. So 2 times 6 is 12, plus 2 is 14. So anyway, 14 hydrogens and 6 carbons on this molecule. Number 3 is asking what type of bond connects each carbon to its neighbor, a single, a double, or a triple bond? Well, if you look between each individual carbon atom, here, here, I've only got 1 stick in between there. So these are single covalent bonds. Okay. Now on to part 2. It says replace the single bond between carbon 2 and 3 with a double bond. So I'm going to start counting from this side of my molecule. So this is carbon 1, carbon 2, and carbon 3. So my bond in between carbon 2 and carbon 3 is here. I'm going to remove it, and I'm going to replace it with a double bond, which means I have to use these other bendy connectors here. So I'm going to replace one of the bendies with my first single bond, but I have to have a double bond. That means I have to have a double connection here. In order to do that, I have to take off 2 hydrogens so that I can make room for my bendy connector here. There we go. Now I've replaced my single bond between carbons 2 and 3 with a double bond. So number 4 says, what do you need to remove from the molecule in order to fit the double bond? I had to remove 2 hydrogens. Now I want to count the number of carbons that I have in my molecule. Go ahead and count those. I still have 6. I didn't remove any of those. And now I have to count the number of hydrogens. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that should make sense because if I started with 14 and I took away 2, 14 minus 2 is 12. So I've got 12 here. Did the number of carbons change from number 2 on the paper? No, I still have 6. Did the number of hydrogens change from number 2? And the answer is yes. it says explain why that happened. So go ahead and pause the video and tell me, why did the number of hydrogens change from 14 to 12? So the number had to change because I had to remove 2 hydrogens to make room for the double bond. All right, part 3, replace my double bond with a triple bond. Well, in order to do that, I'm going to need to use another one of these bendy connectors, but in order to connect it, I've got to take away my 2 other hydrogens that I have here and probably connect this a little bit differently so that I can make space. Here we are. All righty, there we go. I have replaced my double bond with the triple bond. There it is. So part 3 says, what is the name of this molecule? Well, I still have 6 carbons. So it's hex is the prefix. And since I have a triple bond here in my molecule, my ending is YNE. So this is a hexane. But I've also got to tell the reader where the triple bond is. You always start counting your carbon chain on the side of the molecule that is closest to my triple bond. So my closest end to the triple bond is right here. This is carbon 1, carbon 2, carbon 3. So the lowest number carbon that is attached to the triple bond is carbon 2. So the name of this molecule is 2-hexane. And I'm going to pause this for a second so I can write that for you. All right, here it is, 2-hexane. And that is the name of this molecule because my triple bond, which is indicated by the YNE ending, is on carbon 2 of a 6-carbon chain. That's what this name means. So the thing to remember is that the names of these organic molecules are really just codes that are telling you how many carbons there are, what kind of bonds exist between the carbons, and where those multiple bonds are actually located. Okay. So it just says, again, numbers 8, 9, and 10 are similar to the other questions that we've already had to answer. So it just says, number 8, what did you need to remove from the molecule in order to insert that triple bond? Well, once again, I had to remove 2 more hydrogens. So number 9 says, count the number of carbons. 1, 2, 3, 4, 5, 6. And then it's asking me to count the number of hydrogens. Here we go. I'm going to start from this side over here. 1, 2, 3, 4, 5, 6, 7. I don't have any hydrogens on these 2. 8, 9, and 10. So did the number of carbons change from number 5? The answer is no. Did the number of hydrogens? The answer is yes. And then why did that happen? Well, go ahead and pause the video here so that you can answer. All right, the reason why that happened is because in order to insert a double bond, you had to remove 2 hydrogens so that your carbons could accommodate that. Remember, every carbon can only hold 4 bonds, and that's it. So if you have a triple bond, like let's look at carbon number 2 right here. This carbon has 1 single covalent bond between carbon 1 and itself, and it's got 3 covalent bonds between itself and carbon number 3. It's got 4 total bonds. This carbon here has 4 bonds attached to it. That's the most it can hold. So we had to take away 2 hydrogens in order for it to accommodate that triple bond. All right, now we're on to part 4, and it says, now replace the triple bond with the single bond again. So I'm going to pause while I do that. Okay, hi. All right, so I've gone back and I've remade my hexane molecule because it told me to put a single bond in for my triple bond, and it told me to replace any other atoms that I had taken away. So here we are. I've got my hexane molecule again. So number 11 said, describe what you had to do to make this happen. I had to add, I had to take away the triple bond, add the single bond here, and then I had to reconnect 4 hydrogens. So that's your answer for number 11. Oh, wait, I'm sorry. That's what I had to do in order to make the hexane. Part 4 says, next, connect the carbons at the end of the molecule with a single bond in order to form a ring of carbons. Okay, so in order to do that, I need to get another single bond connector, and but like this end carbon right here, there's no more holes here. I can't put anything in. So in order to create that, I've got to take off my hydrogen, and I'm going to put this bond here, and then to make a ring like so, again, this carbon at the end, it's already got 4 bonds. So in order to fit it into the other bond, I need to take away a hydrogen, and now I can connect it in order to form a ring like that. So for number 11, it says, describe what I had to do to make it happen. I had to remove 1 hydrogen from each carbon on the end of the molecule and then join them together. The name of this molecule is cyclohexane. Tell me what this name means. It means that I have 1, 2, 3, 4, 5, 6 carbons that are bonded to each other with single covalent bonds. That's what the ane ending means. And that it's in a circle, cyclo, like a cycle. So cyclohexane just means 6 carbon atoms bond together with single bonds that are in a ring. Okay, number 13 says the formula for water is H2O. You know that a water molecule consists of 2 hydrogen atoms and 1 oxygen. What is the formula for hexane? Well, my formula for hexane would be C6 because I have 6 carbons, and H 2, 4, 6, 8, 10, 12. 6. I have 12 hydrogens in the entire molecule. So my formula would be C6 H12, like that. Okay, I am going to let you answer number 14 and 15 on your own. So I'm going to pause it here. And that is how you do activity number 4. All right, I'll see you guys in class. Thanks for listening.